There are different ways to draw a model, and one of the things you have to decide is what kind of view do you want to show? Do you want to show a macroscopic view? Macroscopic means big enough to see. In other words, you're drawing the way it really looks. Or are you looking for a microscopic view where you're showing what it looks like under a microscope, something that's too small to see with your eyes, but you can see it under a microscope? Or there's something called a submicroscopic or molecular view. I'm going to call this molecular because it's small enough to see molecules, which really can't be seen with a microscope. Molecular means that you're seeing at the level of molecules and atoms. Take an onion, for instance. If I wanted to draw a macroscopic view of the onion, I would draw it to look something like this. So my macroscopic view might look like just an oval shape, the little stem on the top, maybe some lines on it. In other words, it's just a simple drawing of an onion. But a microscopic view of an onion would have to show the cells that are in the onion. Here's a microscopic photograph showing the cells in an onion. If I draw a microscopic view of an onion, I have to show the cells. So I would draw something that looks more like this, with different sort of box shapes, similar to the photograph I just showed you. And maybe with a dot inside where the nucleus of each cell is. That would be a microscopic view. But a molecular view shows the atoms and molecules that make up the object. Onions are made of atoms of carbon and hydrogen and oxygen and several other elements, and I would have to draw a model that shows, probably with little circles, the different atoms and molecules that are in an onion. And that would be a submicroscopic or a molecular view of an onion. For our food dye experiment, we recorded a model that shows what the food dye looked like after 10 seconds and after 2 minutes. Here's my view from my experiment using green food dye after 10 seconds. And here's what my food dye looked like after 2 minutes. Now I'm going to draw a model that shows the food dye. I'm going to concentrate on the 2-minute model where there's the most difference. And I want to show the macroscopic view and the molecular view. Not microscopic, because a microscope can't really see the molecules. So this is going to be my hot water glass right here. I'll make that my cold water glass because I had the cold on the right. Here's my hot water glass. Okay, not being really careful here. So I'll call that hot. And that one is cold. And I had green food dye, so I'm going to use some green. And let's put our water in there. And for the macroscopic view in the cold, it was something like this. There was a little bit of a line coming down, and then it was kind of spread out towards the bottom. And then for the hot, it was more spread out all through the whole glass. Okay, if you were going to color with colored pencils instead of markers, you would probably shade the hot just a solid light color to represent the picture. And the cold, you would probably shade it with a little darker here compared to the hot, because this was a little more concentrated. There was more food coloring in that area. And then there was some clear water, and then there was some dark food color coming down. But how do I show the submicroscopic view, the molecular view? Well, to do that, we use a little trick that looks like this. I'm gonna show it over here first with the hot. I put a circle to say that's the part I'm gonna look at. And now I'm gonna blow up that circle by putting a couple of lines out like this and say, this is what's inside that tiny little circle. This is gonna show my molecular view that's in that little circle. And I'm gonna do the same thing over here, and I'll put it right there. And then I'll show the view up above. Okay? You don't have to be really perfect, but you'll get the idea. All right, so for the hot water, I'm gonna have a certain number of water molecules, and I'm gonna make sure, because the water is just as much water here as there is over here, I have to keep it equal. And I'll use blue for my water. So I'm gonna say I'm gonna put 10 water molecules in here, randomly scattered. 5, 6, 7, 8, that's 9, and 10. 10 water molecules, and I'll have 10 water molecules over here as well. 2, 3, 4, 5, 6, 7, 8, 9, 10. Randomly scattered. But my water molecules are moving. In the cold water, they're moving slowly. So I'm going to use short arrows, and the water molecules are moving in random directions. They're not all moving in the same direction. They're moving in random directions, but slowly. Short arrows mean they're moving slowly. This one too. And the hot water molecules are moving quickly, and long arrows mean fast movement. And it's okay to have the lines crossing each other. Okay, there's my hot water molecules moving quickly. For the food dye, in the cold water, the food dye is more concentrated, but it's only concentrated in this little circle here. It's concentrated in the center. So I'm going to use green circles for my food dye, but I'm going to show them concentrated toward the center. Now, if I did the part down at the bottom, I would have food dye through the whole circle, because the bottom has food dye spread all around, but it would still be very concentrated. And there might be just a few food dye molecules off to the sides, but they're mostly in the center. And then on the hot water side, food dye is more spread out. It's not as concentrated, because those fast-moving water molecules are knocking the food dye all over the place. So I don't have as many, and they're more evenly spread out. That's why on this side, the green was very light, because the molecules are spread out. Over here, the food dye molecules are closer together, so the green was darker. Maybe put another one there. Now, when you do this, you have to make sure that you put in a key as well. You got to show what everything means. So I'm going to say key, a blue circle is water molecule, green circle, food dye molecule, and for the arrows, slow movement and fast movement. One of the things to keep in mind when you're doing a model like this is that we're trying to keep it simple. We don't want to make it complicated. It's a model. It's just supposed to show us what's happening. So some of you might be thinking, wait a minute, a water molecule is not just a circle. Some of you might know that a water molecule actually is H2O. H2O means 2 hydrogen atoms and 1 oxygen atom. If we were to draw a water molecule the way it really looks, it would look something like this. 2 hydrogen atoms and 1 oxygen atom. But that doesn't really help us to make this model. We don't need to know that that's what a water molecule looks like. We need to know that a water molecule is moving slow if it's cold and fast if it's hot. This doesn't help us. When we're making a model, we're trying to keep it simple to make it easier to understand.